evaluation. From evaluation point of view, we have analyzed energy consumption, trying to reduce it efficiently, activating the device at specific time intervals. In fact, continuously checking if the parking space is occupied when it already is not an efficient solution, because the situation will hardly change in a short time. Therefore, we decided to check the parking status, varying the measurement time intervals, putting the device in sleep mode between one data measurement and another, based on the situation in which we find ourselves. If the parking space is free, it's easier to be occupied in a short time. So let's measure the situation with an high frequency through the sensor. Our idea is to measure the data every minute. If the parking space is occupied, there are less chances that it being vacated in a short time, so measurement is less frequent. In this case, the idea is to measure the data every 10 minutes. In addition to analyzing the consumption related to the electronic part, we also investigated on the activity of sending data in order to optimize battery life. Sending data is the most expensive duty from an energy point of view. The data is not sent at each measurement, but only when there is a change in the parking status. The first status is from empty parking space to occupied parking space, and the second status is occupied parking space to empty parking space. Devices consumption. We have assumed that the battery is a power bank of 14,000 milliampere. The ultrasonic sensor consumes 15 milliampere per hour, and the board, STM32 Nucleo board, consumes 12.7 milliampere per hour in run mode and 0.82 milliampere per hour in sleep mode. We have chosen three specific cases. First case is a constantly connected device. In 1 hour, the device consumes 27.7 milliampere. In 1 day, it consumes 664.8 milliampere, and so the device discharges after approximately 21 days. The second case is if device have always free parking. We check parking situation in this case every minute. In 1 hour, the device consumes 1.26 milliampere. In 1 day, it consumes 30.42 milliampere, and so the device discharges after approximately 460 days. This is the worst case from the energy point of view. The third case, the best case, is if device have always occupied parking. In this case, we check parking situation every 10 minutes. In 1 hour, it consumes 0.864 milliampere. In 1 day, it consumes 20.736 milliampere, and so the device discharges after approximately 675 days. So, in real operating situation of the device, the battery life varies from a minimum of 460 days to a maximum of 675 days, against only 21 days if the device is constantly in run mode.